Now, this really is pretty much a review of what you learned in prerequisite courses, but you might not have done all the homework there. Okay, we have the second system of equations. That's the one that gave us two parallel lines, one with an intercept of 0, -4, one with an intercept of 0, 2, both with slope 3. So we know those lines don't meet. Let's see how that works out if we do the algebra. Okay, well, I want to add two equations to eliminate one of the variables. So what I'm going to do is I've got a y here and a y here. I'm going to multiply this equation by -1. So I'm going to end up with a y and a negative y, which is going to give me 0. Okay, so I multiply this y by -1. Of course, I've got to do the same thing to the other side, or my equation is this equation would no longer be equivalent to this one. But if I multiply both sides by -1, I get an equation that is equivalent to this one. Solutions will be exactly the same. There's nothing algebraically valid that you can do to this equation to solve it that doesn't give you the same solution as this one does. Okay, well, we have this. We rewrite this by distributing the negative through here. We get -3x minus 2. We get -y. And now we simply add what we have. Y and -y gives us 0. Okay, well, 3x and -3x gives us 0. -4 and -2 gives us, -6. So that by eliminating y from the equations, we also eliminated all of our x's, and we ended up with the equation that comes down to 0 equals -6. Okay? Now, forgive me for lapsing into vernacular. I do that for emphasis here. And I was just thinking about the fact that there are people in India and the Philippines and lots of places that are watching this, and often watching translations, or people who aren't Native American speakers. So let me just caution those people that my grammar here is officially incorrect, not consistent with what you've learned, not consistent with what you would learn if you don't know English and we're learning it, and I'm not sure how that's going to translate. But I will say, this is the vernacular. Ain't never so, so ain't no intersection. Good thing, because those lines are parallel, but they don't coincide. Well, what am I saying here? I'm saying ain't never so really means that it's never true that 0 equals -6. Okay? There is no set of values for x and y that will make 0 equal to -6, which means there is no set of values for x and y that satisfy both equations. And we can see why. If we graph these equations, we get parallel lines that never meet. There's no intersection. So there's no point xy that's on this graph that's also on this graph. If there was, we'd get a solution. But we get a statement that's never so. That means there is no solution. There is no common set of x and y values that satisfy both equations. And that's all that's really being said here. Okay, excuse me. Still allergy season. Okay, we take this system, 2x plus y equals 6, 4x plus 2y equals 12. Now we're going to try to eliminate x or y by adding multiples of the two equations. And we can make that happen if we want to get rid of x. Well, if we multiply this equation by -2, we're going to get a -4x, and match that up with the 4x, and the x's will go away. So that's our strategy. So we multiply the first equation by -2, we get, well, this. We just put the -2 in front of the left-hand side and the -2 in front of the right-hand side. And then we simplify. Well, then we write the second equation. There's our system. All we've done is multiply both sides of the first equation by -2. And then we come down here and simplify this. We get -4x and -2y, there we have it, and -12, there we have it. So now we add these two equations, and sure enough, -4x matches up with 4x and gives us 0. Well, but You know, look what happens with y. Negative 2y and 2y add up to 0. Negative 12 and 12 add up to 0. So now we get 0 equals 0. Well, that looks a lot like this, except that this is never true, and this is always true. 0 is equal to 0. So we get a true statement out of this, and it didn't depend on what x and y were. Just that x and y, if x and y give us a solution to one equation, then they have to give us a solution to the other. And there's no great mystery in why that is. If we double the first equation, we get the second. Now remember what happened when we graphed. When we graphed, the two graphs coincided. The white graph and the purple graph, they had the same x-intercepts and the same y-intercepts, so the two graphs that formed lines that were exactly the same. So the graph of this line is the same as the graph of this line, and it follows that any x and y that satisfies one satisfies the other. So our solutions to the equation consist of all x and y values that satisfy either equation. So it's always true. So I say any xy with 2x plus y equals 6 is a solution. And I could say the same thing, any xy such that 4x plus 2y equals 12 is a solution. Okay? And this is as expected because the graphs are identical. So we see that we can algebraically coincide with what our graphs are telling us. So it's very important to have the geometrical picture, the graphical picture, and also very important to be able to do this algebra.